In this lesson, we're going to examine how exponential functions can be transformed, that is, changed. Like any other function that passes a vertical line test, and exponential functions do, we can transform them according to a variety of situations. So this is an exponential function that's growing, passes a vertical line test, only passes through once. So we can do some things. We can stretch, compress, reflect, move it up, down, left or right. And the nice thing about this is it works exactly the same way as we've always done things. So when I get an exponential function, and that has a base. Now base is the letter A. Okay, that's what the exponent is acting on. So for example, y equals 3 to the x. The base would be 3. Every other number that gets added to this equation, however, will transform the function. So I put something out front, put a 2 out front, that's your b value. That's going to be a vertical stretch, compress, or reflect. So we have to multiply our y values by that number. So if you saw a 2, we'd be vertically stretching it. If I add things after the bracket, or after the exponent, plus 1, that's also a y thing. That's your c value. And that moves things up or down. And you can just add or subtract your y values. When we add things to the exponent, in other words, to the x part of the equation, okay, so up here, those are your x values. And you might remember with x values, you have to do the opposite. So if you were to put a number in front of the exponent, the letter k, that would be a horizontal stretch, compress, or reflect. But remember, it does the opposite. So if I saw something like 2x out front, that means it would be a horizontal compression by half. If I saw something after the exponent, so plus 3 over here, that could be your left or right. Now be careful, notice the format that the equation is written in. The k has to be outside, and the d has to be inside a bracket. So actually, let's erase this a little bit just to be a little bit easier to see here. So if I were to see y equals 2 bracket 3, and we had a 2 and an x plus 3 and a plus 1, that would be an exponential equation in the right format. And the 2 would be our vertical stretch. This 2 would be a horizontal compression. This would be a left 3, and this one would be an up 1. And those ideas are the exact same ideas we did when we looked at our first parent functions. Our parent function here happens to be 3 to the power of x. So let's look at some transformations. Our parent function this time is y equals 2 to the x, so always having a base of 2. Any other numbers besides that base of 2 are our transformations. So here, I see a 3 out front. A 3 out front means it's a vertical thing, and it's bigger than 1, so it's a stretch by a factor of 3. I also see a plus 1 afterwards. That's after the bracket, and those are y things. So this is going to be up 1. Look at the next one. There are actually 4 things going on here. We'll number them. 1, 2, 3, and 4. Okay, the 2, remember the base right here, is not a transformation. It's the parent function. It's referring back to the one we started with. So what does number 1 do? A negative sign. That's a vertical reflection. It's vertical because it's outside the bracket. It's a y thing. Number 2 is a vertical compression. And it says cut it in half. So we're going to vertically compress it by a factor of 1/2. It gets smaller vertically. Number 3, that's inside the bracket. It's acting on the x's. X's do the opposite. So instead of adding 3, we have to subtract, or in other words, we go left 3. And number 4, outside the bracket, a y thing, we're going to go down 5. And as I've been saying, those are the same kind of transformations you would have done when we looked at absolute x or root x or any of those other ones. Let's take a look at C. And C, the first thing you hopefully will notice is that our equation's in the wrong format. The exponent has 2 parts on it, but no brackets. We're not supposed to have that when we're talking about transformations. So we're going to change this. Our base is 2. The part outside the bracket is 2, but when I factor that out, I get x minus 3 inside. I need to have 2 distinct parts to the bracket when I look at transformations. So what's going on here? Well, the first one, the 2, that would be this 2, is a horizontal compression, okay, by a half. And remember, things that affect the x's do the opposites. So we're not going to double them, we're actually going to half them. And the part inside the bracket, we're going to go right 3. And so some quick reminders of transformations. Once we've discussed the transformations, we can sketch these functions. And we do it the same way we did with parent functions back at the beginning of the course. You have a parent function table and you need to transform it. Okay? So we're trying to figure out what your parent function is. Think of what would happen if I got rid of all the numbers except what the x is on. So in this case, the x is on the 3. So my parent function is 3 to the x. Everything else is a transformation. I can make a table for this. Our standard table is -2, -1, 0, 1, 2. And we'll figure out what happens when I use x as my exponent. So in the first instance, if we turn x into 3 to the power of -2, right, think about negative exponential, what happens? We get 1 over 3 to the 2, or in other words, 1/9. And what happens if x is -1 this time? We'll do the exact same equation, except we'll make it -1. What happens there? We get 1 over 3 to the 1, which is just 1/3. Try the next one. 3 to the power of 0. Well, that's a nice one. That's just 1. 3 to the 1 is 3. 3 to the 2 is 1/9. That's my parent function. I can sketch that. My sketch would look like -2 1/9, -1 1/3, 0, 1, 1, 3, and 2, 9 will be way up there somewhere. And there's my exponential growth, which makes sense because my base is a whole number. It's bigger than 1. That should be exponential growth. If we try actually sketching the new transformed functions, we'll do letter A here first. We have to apply some transformations to this table. This is a y thing, and so is this. So double the y's and subtract 1. My x's will stay the same. So -2, -1, 0, 1, 2. My y's. I have to multiply them by 2 and then subtract 1. So if we do the first one, that's the 1/9. We'll get 2 times 1/9 is 2/9. Minus 1 is -7/9. We'll do the same thing to this one. 2 times 1/3 is 2/3. Minus 1 is -1/3. 2 times 1 minus 1 is 1. Then 5. Then 17. And we can graph that. Okay, so -2 and -7/9 is down here. -1 and -1/3. 0 and 1. 1 and 5. 1, 2, 3, 4, 5. And we get a function that looks like this. It's been stretched and it's been moved down. Okay. I'll try the same thing for B. Maybe give this a pause, see if you can try it yourself. What do we have going on here? We've got 1/2 times y. This is a y thing outside. And then we've got inside x. It says add 1, so we're going to subtract 1. You notice we're working off the green table, right? That's our parent function. So -3, -2, -1, 0, 1. Half of y. Half of a 9th is an 18th. Half of a 1/3 is a 6th. Half, 3 halves, or 1.5, and 9 halves, or 4.5. Okay, let's try sketching this. -3 and an 18th is almost on the line there. It's really hard to even draw that. A 6th. A half. 0 and 1.5. 1 and 4.5. And my graph looks like that. And they're all still growing. They're all exponential growth. Our base is still 3, but they've been transformed. They've been moved, stretched, compressed, all kinds of different things. Okay, so that's how we sketch things. The last thing I want to look at is some properties of exponential functions, so things that are in this form. There's 3 properties we want to worry about. The first one's called a horizontal asymptote. And the way a horizontal asymptote works is it's an imaginary line that's approached but never crossed. For a standard exponential function, this is the x-axis. But when we transform it, we're going to move it according to c. c is this number back here. So let's go back for a second to this graph we just drew. If you look back at the green graph, the line that this graph approaches but never crosses is the x-axis. The green graph gets closer and closer, especially over here on the left-hand side, to that line, but it never actually crosses it. If you look at your table of the green values, there's no way you're going to get a negative number. You're never going to hit 0, much less get below 0. And you can think of the smallest x value you want, and 3 to the power of that will make a really small decimal, but it'll never make negatives. Okay. When we transformed something, the red one let's talk about, and moved it down 1, it changed what we approached. That line approached -1, the red line. Take a look at it. Over here, it gets closer and closer and closer to -1, but it never hits it. So the number at the end, in this case -1, in this case 0, is our horizontal asymptote. If you look at B, there's no number over here. It also approached 0. If you look at your blue graph, you can see it gets closer and closer to the x-axis, but never hits it. So that's property number 1, the horizontal asymptote, the c value. Okay, it's an equation, so we usually write it as y equals whatever c happens to be. Property number 2, we already know about the shape of the curve. Is it growth? That means it's bigger than 1 base, or is it decay? That's between 0 and 1 base. So it's a fraction, a third, a fifth, a seventh, something like that. And the third thing we should be able to find is our y-intercept. We know we can find y-intercepts by making x equals 0. Sometimes you can see it right on the graph. We got our y-intercept right here, right here, right here. And you can look on your graph, they're all right there. Sometimes you can just calculate them using an equation. Okay. So last example here. Oh, sorry, one more page. Write 2 different equations to represent an exponential function with a y-intercept of 5 and an asymptote at y equals -2. So I need an equation, something with an exponent on it. I've been told I have a a horizontal asymptote of y equals -2. That number is my c value. It has to go here. It doesn't tell me if this is a growing or decaying function, so I can pick any base I want to. So let's pick number 2 just to make life easy. And the other thing it does tell me is I have a y-intercept of 5. That means when x is 0, y has to come out to 5. So let's try the equation I have right now. If I were to put 0 in, put off to the side here, 2 to the 0 minus 2. I'll get 1 minus 2, which is -1. That's not the y-intercept I need. I need to make a y-intercept of 5. So I can't change the asymptote part. I can't change the base part, but I can put something out front if I want to. In other words, I can stretch or compress this. So for example, if I were to put a number out here, so this comes out to 5, what would I need to have up front? I would need to have a number such as 7, because 7 times 1 is 7. I'm going to subtract 2 and get 5. So if I go back to the top now, I'll put a 7 out front, I have an answer that will work. I have to do a little bit of problem solving, a little bit of thinking. Now the question said write 2 different equations. I'm not going to write another one. All I need to really do is change my base. Maybe I say, well, I'm going to make this one a decaying model. It still has the same asymptote. Still, when I put the 0 in to find my y-intercept, I get 1/2 to the 0. Gives me 7 times 1. Gives me 5. I'll get the right properties. Okay, so you have a lot of choices on how you make an exponential equation. There's lots of different ones that can fit the properties that you need. You try the next one. So give it a pause and see what you can do. So we want an increasing function. It's got a range greater than -1, and it has a y-intercept of 5. 3 things I have to hit. Okay, so exponential, and it has to be increasing, which means you need a base bigger than 1. By saying it has a range of y is greater than -1 means it never hits -1. That's a tricky way of saying, here's your horizontal asymptote, -1. And I need a y-intercept of 5. So when x is 0, I need it to come out to 5. So right now, if I were to try it, 3 to the 0 minus 1 would give me 1 minus 1, which is, 0. I need to make this bigger. I need to multiply this by what? Make it come out to 5. If I make this a 6, makes this a 6, makes this a 6. There's an equation that will work. Okay. And last idea. So, I've given you the equations this time. Let's work backwards and figure out the properties. So, part A, find the horizontal asymptote. So we'll do example number 1 first. Okay. Flip that around. Example 1, part A. Hey, my horizontal asymptote, right there. Y equals -8. Okay, part B, is this increasing or decreasing? That's from my base, what the exponent is on. That's bigger than 1, so this is an increasing function. The y-intercept. To find the y-intercept, we make x equals 0 and see what happens. So 9 times 3 to the 0 minus, plus 1 minus 8. Well, that's going to give me 9 times 3 to the 1 plus 8, which is just like 9 times 3 plus 8, which is 27 plus 8. In other words, 35 is my y-intercept. The domain. The domain is kind of like a trick question for exponential functions because they go left and right forever and ever and ever. So our domain is all real numbers. And our range, also kind of a trick question. It depends on your asymptote. You approach but never cross it. So y has to be greater than, not equal, don't put a line underneath it, just greater than -8. Based on your asymptote, of course. Okay, can you guys try the last one, please? Okay. Notice in this question, it's not in a good format. The exponent has 2 parts, but no brackets. We need to factor first. And then we can try some stuff. Okay, our horizontal asymptote. That's over here. There's nothing there. Go with the standard one, approaching 0. Our base, the fraction less than 1, decreasing. Okay, y-intercept. I make my x become a 0. See what happens. Okay, so I'll get 1/5 times 3, 3 to the times 2, which is 1/5 to the 6, which, if I apply that, 1 to the 6 is 1, and 5 to the 6 is 15,625, I believe. Yep. Okay. Domain range, 2 little trick questions almost. Our domain's all real numbers, and our range, depending on our asymptote, has to be greater than 0. Okay, so that's our last lesson on exponential functions. Just some basic things reminding us of how to do transformations, recognizing some basic properties, and drawing some basic graphs given the equations. Okay, our homework today is on the handouts on the website. You can give it a try. Make sure you can do it. If you're stuck with stuff, come see me, and we can figure it out.